Okay, so here we're going to look at the solution for the final blurring, which uses the, what is that called, the Manhattan distance, and then it has a much more fancy and elegant name, or not elegant, but elongated name. I think that'll be the correct word. So we're going to look through the solution and what it does, but basically it takes a number past 10 and then it calls toString on it, and then it calls toInteger on it. I think that's a little bit paranoid to do both of those things, but this author does that. If you remove that, it should work still just fine if you just set n equal to number. Then it says for however many n's there are, or however many numbers you get passed in, so 1, 2, or 3, however many that times, do the following thing. It's going to create a new variable called b, which uses Marshall load and Marshall dump of the image. What does that do? It creates a copy. It creates a completely unique non-reference copy. If you don't do this, if you just set b equal to image, then it's going to, every time the image changes, b is also going to change, which we don't want. So then you loop through the image, and each of the top rows is called y. Then within the rows, you loop through them, and that's going to give you the x value. If b of y and x, so y being the first array and x being the inner array, if that is equal to 1, then perform the following operations. First, look at the image, find the y value, and go up 1, and set that equal to 1 unless y is equal to the image length minus 1. If the image length minus 1 is true, that means that you are all the way at the bottom, so going one more down on the y-axis isn't going to do you any good. It's going to throw an out-of-bounds error. Likewise, for the next one, you go up 1 by subtracting 1 from y, unless y is equal to 0. For the x-axis, we do the same thing. We look at the value of y, then we go x plus 1 equals 1, unless the image place y.length minus 1 is equal to x, which means we're already at the very farthest end. And then finally, we do the same thing for left. We go minus 1 unless x equal to 0, which means we're already at the farthest left-hand side of x that we can get to. So again, it'd be an out-of-bounds area. Then, since it's looping through n times, image is going to change with each of these, right? So image is now mutated. So it's gone up, down, left, and right 1. Well, then the next time it loops through it, again, it's going to look at the ones, and it's going to go one more left, one more right, one more up, and one more down for each of the places. That's the reason why this works. Now, another way to write that is like this. And here, all I've done is I've broken it out bit by bit. So instead of having it all on one line, which is what's known as idiomatic Ruby, this version breaks them out and uses the full unless statement. Unless y equals image length minus 1. So if this is true, we're at the end of the y-axis, then go down. Unless y equals 0, which means this is true, we're at the beginning of the array. Pretend we're at the beginning of the outer array. If this is true, we're at the last element in the x-axis. And then finally, this one, unless x equals 0, which if that's true, then we're at the beginning of the y-axis. Now, yet another way that you could write that is unless can also be if not equal. So if y does not equal image length minus 1, go down and make that value 1. Same thing is true here. If y does not equal 0, do this. If y does not equal image length, so forth and so on. You can see the original solution right here is much more terse. It's only got 1, 2, 3, 4 lines. The alternatives have, if you don't count the white space, you got 2, 4, 8. You got 8 lines, so it's doubled the amount of code. Or actually, it's even tripled it, I think. Yeah, because it's 3 lines for each of these. So you got triple the amount of code, but it might be a little bit easier to read if you're brand new to Ruby. So that's how the Manhattan distance works, is it loops through it a number of times, and because the image gets changed each time it loops through, it'll then go one up, down, left, and right for each one value that it finds, which will eventually give you a fully Leffenstein, I think, formula, something like that. But that is how this works, and here are the alternatives. I will post them in a gist, and I hope that makes it a little more clear. And the only other thing that I did is I switched out the test library he was using for the Ruby default one, because it gives you this really nice syntax right there, that visual cue. I love that. The other one doesn't. It just does stuff. So I like it, this version. All right, I will see you in a couple hours. Bye.